Hello, beautiful people, and welcome to trigonometry. So, trig is the study of relationships between the side lengths and angles of the triangle. So, we're going to be talking about right triangles, 90-degree triangles. We're going to be talking about all types of triangles using trigonometry. And we're going to be using that relationship between side lengths and the angles. Now, if we go into our trig functions, there's going to be certain trig functions that you need to know. You need to know or memorize them. So the first thing I want to talk to you about is what a trigonometric function is. And it is a function whose whose rule is defined by a trig. I'm going to abbreviate trig instead of writing trigonometric ratio. Now, what the heck is a trig ratio? A trig ratio, it compares the lengths of two sides of a triangle. So when I ask you, if you're in my class, we just came from a logarithmic unit. So when I asked you what is a logarithm, you know that a logarithm is an exponent. When I ask you what is trigonometry, what is a trigonometric function, your response to that, it is a ratio of sides of triangles. So again, what are trigonometric functions? They are ratios of two sides of a triangle. So what are the trig functions? And again, you guys, I'm going to not say trigonometric often. I'm going to refer to the abbreviated version of trig. So what are the trig functions? There are three that you need to know, and then we will use those three in order to find what they are. So I'm going to give you a little, I guess, not a trick. I mean, this is a well-known thing, so I'm going to say what everyone does. We're going to do so. Hesitated there for a second, excuse me. Ka, toa. Now, what so ka toa is, it's just an easier way for us to remember what those trigonometric functions are. It helps us to know what the function, let's say, what the function is to the two sides of a triangle. For example, so means we have sine of theta. Now, theta is just your angle measure. Typically, angle measures are used in Greek letters, theta, alpha, gamma, etc. So, means that you have opposite over hypotenuse. Ka means you have cosine of theta equal to adjacent over hypotenuse. And toa means you have tangent, and I shouldn't have rewritten tangent like that, but it's okay. Let's abbreviate it. Tangent of theta is equal to O stands for opposite, A stands for adjacent. And I'm going to bubble those in so you guys can see. So these are our three basic trigonometric functions. Now, since I did write tangent as like the actual word and not an abbreviation, let's write this one here. So sine usually is S-I-N-E. So sine is one of the trigonometric functions. Again, mathematicians, if you're in my class, you already know this. Mathematicians are lazy. So instead of writing sine, S-I-N-E, we're going to abbreviate to that S-I-N. It is not sin of theta. Don't do sin. It's sine, S-I-N. We're just too lazy to write the E. Cosine. Let's write this here. Where should I write it? Right here. Cosine. And tangent. So now there's three more. Now I did run a little bit out of room here, but that's okay. So I'm going to use a sheet of paper here to continue writing what this is. Oh, let's not. Let's leave it there, and I can go back to it. So we have right now, 3 trigonometric functions. We're going to use these trigonometric functions to find out what these ratios are. Now, super duper important to know is when you're looking at a triangle, these are very specific to right triangles. It has to be a right triangle. Now, depending on if you're using sine, tangent, cosine, will depend on where you're looking at. So I imagine this, let's say you're looking through here, this is your theta. Imagine that theta, and it's going to be a little bit weird at first, but that's okay. Imagine that theta is your eyeball. So this is your eyeball, and you're looking through that eyeball. So wherever that theta is, that is your eyeball looking through that. So if this is my eyeball, then that means that my adjacent is right next to it, and my opposite is across from it. Now your hypotenuse is always, always, always going to be across your right angle. Now let's say my eyeball changes. Let's say my eyeball is no longer there. Let's say my eyeball is in a different position. So let's say I have a right angle like this. Here's where my theta is. That means that my eyeball has now shifted. So I'm looking through, I'm just going to draw it here real quick. I'm looking through this angle. Here's my eyeball. Here's my eyeball. I'm looking through this direction. We're looking outward. So that means that across is my hypotenuse. That means my adjacent, trying to keep the same colors and I'm struggling here. That means my adjacent is here, and my opposite is across my eyeball, across my theta. So make sure you know that. There are 2 special right triangles, technically 3, but technically 2 that we're going to be using. The first right triangle that we're going to be using is going to be your 45, 45, 90 or 90, 45. So let's go ahead and draw these out. And these special right triangles are because they are most used, the angles, the 30, 60, 90 angles, 45 are the most commonly or frequent used in trigonometry. You're going to have to memorize these values. So we'll get to that. But let's say we have a 45 degree, and a 90-degree triangle. And then here we have a 30-degree, 60-degree, and a 90-degree. Now this one here, 30, 60, 90, you can look through both eyeballs. So you can look through the 60-degree and have that be your theta, or you can use the 30 and have that be your theta. That's where those values matter. If you have a 45, 45, 90 triangle, it follows this pattern. So whatever your side length here of x is, your side length here of x will also be that same value. And then your hypotenuse value, your length, is always x root 2. So if I have 2 as my x, 2 as my x, 2 root 2 is going to be my hypotenuse. And again, this pattern only works for 45, 45, 90 triangle. Now let's say we don't have that. Let's say we have our 30, 60, 90 triangle. Our pattern is this. X is on the length between 90 and 60. X root 3 is on the length of 90 and 30. And then our hypotenuse is 2 times our x. So if x is 2, so we have 2 root 3 as our side length here, and we have 2 times 2, which is 4 as our side length here. Memorize this pattern. It's going to be very helpful. Now let's talk about our trig ratios of special angles. So what you're going to need to do is memorize this. Now I'm going to be posting in a separate video on how to memorize these angles and the ratios. It's super duper easy. All you need, honestly, is your left hand and the right quadrant of the unit circle, and you can memorize it. But for example, let's say we have, let's do this, sine of 45 degrees. We want to know what the sine of 45 degrees is. Now let's say we have an angle, a triangle that looks like this. Here's 45, and here's 90. So we have, again, x root 2. And from this, oh, you guys can't see, I apologize. From this triangle, I want to know what the sine of 45 degrees is. Now, again, at this point, you don't have these memorized. That's fine. I don't expect you to. But let's talk about how you would solve something like this. Let's say, for an example, this is our triangle. This is what we're trying to find. Let's go back to our trigonometric functions. What are trigonometric functions? They are ratios. In this case, sine is the ratio of the opposite sine to the hypotenuse side. So we have opposite over hypotenuse. What is the opposite? Well, it all depends on which angle you look through. The 45, 90 degree triangle technically doesn't matter which angle you look through because it's the same angle. So let's say our eyeball is here. I'm going to color in our eyeball, so I'm going to look this way. This is where my eyeball is. That means the opposite the opposite side is x, and then the hypotenuse is always across from the right angle is, oh, I forgot an x here. That would have been bad. Hopefully you caught that before I did. X root 2. Now, in trigonometry, you're never going to be, unless they ask you to round, you're not going to be using decimals. Fractions are your friends, and you always want to rationalize the denominator. So if you have like a root 2, root 3, you always want to get rid of that. And the easiest way to get rid of that is because this is multiplication is king, take whatever root you have, multiply that top and bottom. Now, be careful, be extremely careful. This does not just cross out. This doesn't just disappear. This gives us x root 2 divided by x times root 2 times root 2. Root 2 times root 2, that gives me root 2 squared. And that means my square root and my square go away, but that 2 inside of the root stays. So what I have here is x times root 2 divided by x times 2. Because multiplication is king, that means I can get rid of my x's. So that means sine of 45 is root 2 over 2. Now also be careful, we will be talking about different measures of angles. There are radians, there are degrees. This matters right here because this is in degrees. Make sure your calculator is in degree mode if you are asked to round any of your answers. Let's do a couple. Actually, you know what? Before we move on, let's go ahead and continue with our trigonometric functions. There are 3 more that I forgot to mention that I will mention right now. So we know the trig functions. If you don't remember, always remember SOHCAHTOA, and then you'll know what they are. So SOHCAHTOA. Oh, you can barely see that. Hopefully, if I zoom in, that you can see that better. SOHCAHTOA. So that means I have sine of theta is equal to opposite over hypotenuse. That means CA is equal to cosine, is equal to adjacent over hypotenuse. TOA means tangent is equal to opposite over adjacent. So again, we've done this. You already heard this from me in this video. Now, besides these trig functions, we also have these reciprocal functions. So not only do you have to memorize sine, cosine, tangent, and I forgot my theta here, you also need to memorize the reciprocal functions and what those are. So what does it mean to be a reciprocal? A reciprocal means that you're taking whatever fraction you have and you're making it like flip-flop. So if I have 2/3, I'm flipping it. I have 3 on top, 2 on the bottom. So for my reciprocal functions, I'm going to just drop it down here a little bit. So if I have for a reciprocal 1 over, let's change the color so I'm not always using pink, 1 over sine of theta, 1 over cosine of theta, 1 over tangent of theta. So those are reciprocals, but we flip the fraction. So that means what the definitions are, the opposite over hypotenuse, adjacent over hypotenuse, also needs to be flipped. So now I have, whoop, already messed up. Let's see if I can say this. I can. Hypotenuse over opposite. We flip this one so it's hypotenuse over adjacent. And the last one we have is adjacent over opposite. Now, if you recall, if you're in my class, mathematicians are what? They are lazy. So because we are lazy, we actually have created a different word for these. We don't actually want to say 1 over sine of theta, 1 over cosine of theta. That's too much work for us. So the new words or the new names for these things are as follows. For the reciprocal of sine, this is equal to cosecant. And I'm going to abbreviate it, and then I'm going to write it out. So this is cosecant. The reciprocal of cosine is secant. And the reciprocal of tangent is cotangent. The way I like to remember it, and I always get these two messed up, is since this is the reciprocal of sine, C is my first letter. Since this is the reciprocal of cosine, S is my letter. That's just something that I like to think about when I'm doing these. All right, so cosecant of theta is hypotenuse over opposite. Secant of theta is hypotenuse over adjacent, and then cotangent is adjacent over opposite. And again, I promised to write out these words, so I'm going to just write these out for you. So this is cosecant. This is secant. And the last one is cotangent. Let's go ahead and do one quick example. And with a triangle, this one's going to be 16, this one's going to be 30, and our eyeball is down here with theta. And let's say we want to find all of these. Sine, cosine, tangent. What else do we have? Cosecant, secant, and cotangent. We want to find all of these values for the given triangle. Here's our eyeball. I'm looking through my eyeball. My hypotenuse is always opposite. So notice that there is a hypotenuse missing. We don't have a value. So the first thing I'm going to do is I'm going to solve for the hypotenuse. This one's missing. And how do we find a hypotenuse? We're going to use the Pythagorean theorem. So a squared plus b squared equals c squared. So I have 30 squared plus 16 squared equals c squared. 30 squared is 900 plus 16 squared is 256 is equal to c squared. So then I'm going to add these. So I have 1156 is equal to c squared. So c is equal to 34. So now we have this is 34. Knowing all of the sides of my triangles, I can then continue to use my sine, cosine, and tangent. Sine we know is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Now we know that these are the reciprocals of these, so we're going to flip it. So that means this is hypotenuse over opposite. This is hypotenuse over adjacent. And this is adjacent over opposite. So all we have to do, you guys, is just look at our triangle through the eyeball of theta and see. So what is the opposite? Opposite is 16. What is the hypotenuse? 34. What is the adjacent? Adjacent is 30. Hypotenuse is 34. Opposite is 16. Adjacent is 30. I will go back and simplify that in just a little bit. And we don't even care about this. All I'm going to do is I'm going to take these values and flip it. C goes to S, or S goes to C, so I have 34 over 16. Here I have 34 over 30. I'm not even bothering to look at my triangle anymore. I just know these are the reciprocals, so I'm just flipping those fractions. Simplifying all of these, I have 8, 17, which means this would be 17 over 8. I'm going to go ahead and put a bubble around these. Cosine, I have 17 over, oh, excuse me, I don't have 17, this is 15. Excuse me, my phone just went off, caught me off guard. 15. Then here I have 8 over 15. And again, we're just taking the reciprocal for the reciprocal functions. So we have 17 over 15. and we have 15/8. And that is pretty much it, you guys. Hope you enjoyed this video, and I will see you in the next one. In our next video, we will be talking about how to find side lengths and how to find angle measures for these right triangles. Enjoy your day. Bye.